The X-59 supersonic jet's primary purpose is to collect data from cities and towns across America. This public reaction data will then be used to reevaluate and possibly change the existing ban of flying supersonic aircraft over land. The United States Air Force, NASA, and the Federal Aviation Administration conducted a flight program to study community responses to sonic booms. The selected cities were St. Louis, Missouri in 1961 and 62, Oklahoma City, Oklahoma in 1964, and Chicago, Illinois in 1965. The tests were done to gauge how the public would react to supersonic aircraft. As part of the test, sonic booms were produced each day at different time periods in each city, resulting in scaring and frightening residents. In Oklahoma City, Oklahoma, outraged residents sued the government in a class action lawsuit and won. According to a paper titled Sonic Boom Containment or Confrontation by Anthony J. Ortner, there were more than 30,000 combined formal complaints lodged against these sonic booms in these three cities collectively. This overwhelming rejection of sonic booms played a key role in the ruling to ban supersonic flights over the United States. This is the reason why the flight of the X-59 is so groundbreaking. This one flight could lay the groundwork in overturning the ban which has existed for 50 years. Now, overturning this ban could be monumental for the growth of all aspects of the supersonic aircraft industry. The challenges involved in developing the X-59 were engineering challenges, attempting to fit components in such a small, confined space, routing wires. There are several miles of wires in the X-59, and they all had to be ran in different locations so as one wire would not affect the other. Integrating components. The landing gear in the 59 is from the F-16 and the cockpit is from the T-38. They have never worked well together before. There are also flight control issues. Structural coupling tests. These tests on the X-59 are designed to test control surfaces, including its flaps and its rudders and its aerodynamic forces. These tests are used to see if the control surfaces will work prior to the maiden flight of the X-59, which is scheduled for early 2025. Supersonic aircraft uses more fuel than the traditional subsupersonic aircraft. The 59 aims to address the issues of sonic booms by utilizing the unique design of the aircraft, in particular the long, thin, tapered nose. Helps to reduce the sonic booms by effectively dispersing the shock waves and not allowing them to build up and create a loud boom, instead just a quiet sonic thump. By dispersing the pressure changes over a larger section of the aircraft, essentially the nose shape helps to break up and lessen the shock wave intensity produced by different parts of the plane, producing a much quieter sonic thump on the ground. Engine placement on top reduces the size of the sonic boom. The cockpit of the X-59 does not have a forward-facing window, so the pilot relies on computer monitors to fly the plane. The external vision system, or XVS, improves pilot visibility by essentially acting as a virtual forward-facing window, using a system of cameras mounted in front to provide a real-time video feed and cockpit display of what's in front of the pilot. This external vision system is designed due to the aerodynamic needs of the X-59. This advanced design basically spread out these shock waves and not allow them to make such a loud noise. It produces a sonic thump and not a sonic boom. QUEST stands for Quiet Supersonic Technology. It's the name of the NASA mission to develop supersonic aircraft to prove that they can fly without producing sonic booms. It is the centerpiece of NASA's QUEST program. Once the flight tests have been evaluated by officials, the testing results can then be used to overturn the current ban on supersonic aircraft flying over cities. The General Electric F414 GE100 engine plays a very important role in the performance of the aircraft, as it is the primary power source for the X-59. It provides all thrust to enable it to fly at speeds of Mach 1.4, 925 miles per hour. and at altitudes of around 55,000 feet, with a total single pilot length of 99.7 feet and a wingspan of 29.5 feet. It also has noise reducing capabilities. The key to the X-59 is the ability to achieve quiet supersonic flight, and I believe that this engine will be crucial in making it achieve its goals. It produces 22,000 pounds of thrust, and if necessary, the F-414 engine can turn on its afterburners to give it additional speed when necessary, which were designed to work in concert with the aircraft's other dynamic features. This engine is also used in the Navy's FA-18 Supermort, and this is a very safe, very secure engine. This engine has been tested all over the world, flying in different jets all over the world. I believe it is a perfect choice for the debut of the X-59. The X-59 primarily uses advanced carbon fiber composite materials or structures, including the wings, the nose. Also, it uses metallic structures for the ribs and the rear part of the ship, including aluminum and titanium. Notable technologies include digital design in the multi-material structures. Robotic manufacturing techniques achieve its unique aerodynamic shape at reducing the sonic boom noise during supersonic flight. The test of the 59's performance to gather data on sonic thumps will basically be held in the beginning of 2025. The plane will fly over certain cities across the U.S. The plane will be followed by chase planes. These chase planes will be designed with different probes. These probes will be able to test the characteristics of the shock wave to make sure that they have the correct pressure, to make sure that they are producing the right sounds. These sounds will then be recorded on sophisticated ground equipment. This ground equipment will be turned into the officials. The officials will then certify if the X-59 was making the correct amount of noise level. And then the information and the data will then be turned over to officials to see if the 59 was successful in producing a quiet supersonic thump, and will be able to gauge public perception, public outcome of this flight. Commercial applications resulting from the X-59 are, as I said before, monumental. This supersonic plane can perform the supersonic flights and greatly reduce the sonic noise from a boom to a thump. Imagine what that would do to the supersonic aircraft industry. There would be plane manufacturers studying ways to produce commercial supersonic planes carrying hundreds and hundreds of people from different destinations all around the world, making trips all around the world in remarkably reduced times. There could be reduced sonic booms. These sonic booms could also be lessened on much larger aircraft. There would also be faster travel times. There'd be a new market opening up for supersonic aircraft, and there would be a huge impact on global connectivity. The flight of the X-59 represents the very beginning of opening up a whole new field in flight. This flight is very important. The design of the 59 contributes to the fuel efficiency and the environmental sustainability. It is made of lightweight composite materials. This really reduces the weight, and also the aerodynamic shape minimizes the drag, and especially with the GE F-414 engine, this engine is highly fuel efficient, and it's also has noise reducing capabilities. Those few things give it a very high rating on fuel efficiency. I think the long-term goals for the X-59 supersonic flight and its technology will go a long way into reducing the sonic booms of not just the X-59, but planes further on down the line. Even bigger planes, even commercial planes, will be able to fly supersonic and have little to reduce booms. I believe that the long-term goal, another long-term goal, is just to gather data, and this data can be used as a standard or benchmark for other supersonic aircraft all around the world. I believe that another long-term goal is to establish a commercial supersonic noise standard. I think that the standards will be recalculated or redone based on the public's perception of this new supersonic aircraft. If you've got something out of this video, learned something out of this video, you'd like to share something, I encourage you to like, comment, and subscribe. And thank you very much. Ace Extra.